Hello everyone, welcome to Josh Max channel. In this video, we are going to see for CBSE Max Grade 12 Standard Chapter 5 Continuity and Differentiability in exercise 5.2 sums. So before moving on to the sums part, I would like to explain some of the standard results in the differentiation. Then we can move on to the solving the sums. Okay. So here d by dx means differentiation with respect to x. Okay. So whichever function we would like to differentiate, that inside the bracket I have represented. So x power n, this particular formula will use for any kind of algebraic function. Okay, suppose if it is x raised to some power 5, x raised to 7, x raised to minus 6. If you wanted to differentiate such type of functions, okay, such type of functions, we have to use the first formula. So what is that formula says here? Whatever power you have, bring that power to the coefficient. Okay, you have to bring it to the coefficient of the x, then reduce 1 to the power. Then what happens if you differentiate x power 5? Differentiating the x power 5 will use as per the formula. Okay, so what is the formula says? 5 you have to bring it as a coefficient. So bring it as a coefficient. Then what we need to do? Power we have to reduce 1. Then 5 minus 1 gives you 4. That's all the differentiation. Okay, so x raised to any numerical value, we have to use the first formula. Okay, next one is what? D by dx x. So x differentiation with respect to x is what? 1. So this can be obtained using the first formula itself. See, d by dx, what is the power here? X raised to, if nothing means it's a power 1. Then bring power to the coefficient, then reduce 1 to the power. Then what happens? 1 minus 1, 0. X power 0 is 1. So anything raised to 0 is what? 1. 1 into 1, 1. So that's how x differentiation is 1. Also, um, x with respect to x, if you differentiate, cancel also 1. So you can remember in either way. Okay. Next, third one is e power x. So this is an exponent function. Exponent function, even after differentiation, there is a no change. So e power x differentiation, e power x itself. And next one, a power x. And here I would like to highlight x power n and a power x. Always there is a confusion between these two formulas. So I'll make you clear with this. So what is the first one says? The variable. Okay, x is a variable raised to some numerical value. We have to use the first one. Okay, that means power you have to bring it as a coefficient, then reduce 1 to the power. So 2 minus 1, which is 1. No need to reference 2x. But when to use the a power x? No. If constant rise to some variable. Okay, if constant, then 2 power x, constant rise to some variable, you have to use this fourth formula. So a power x differentiation is what? A power x itself, then into log a. Then 2 power x differentiation, 2 power x, and what is in place of a? We have here 2, then log 2. That's all. You understand the difference between these two? I hope you people understand. So just remember, variable rise to some numerical value, use the first formula. Okay, and numerical value rise to some variable, some function, use the fourth formula. Okay, and next one we have log x. Log x differentiation by default 1 by x. Log x differentiation is what? 1 by x. You have to write it in the whatever function you have to write it in the denominator. Okay, x. And we have 6 trigonometric ratios, right? And is it all trigonometric? The nature of that functions are same? No. Then differentiation of that also won't be same. So each one has a own characteristics. So sin x differentiation, cos x. Okay, just remember the standard formulas, and the proof of these and all, it's not required. Okay, just remember the formulas. Sin x differentiation is cos x differentiation minus sin x, tan x differentiation secant square x, secant x differentiation secant x into tan x, cosecant x differentiation minus cosecant x into cot x, and cot x differentiation minus cosecant square x. I'll tell you in an easy way to remember now. Okay, so sin and cos are like a friends. If sin comes, cos x, cos comes, minus sin x. Same way tan and secant you can remember, cosecant and cot you can remember. Now when to use the minus sign? No, if the trigonometric function start with the letter C, you can notice by default you will have a minus sign. So you will not forget to put the minus sign now. Yes, and also cos x differentiation minus sin x, you can very well remember, but always there will be a confusion between cosecant x and cot x. No, and cosecant, no, starting letter C and ending letter C. That means please understand cosecant x into cot x. So two functions together. So this will reminds you the two functions we have to, the product you have to write cosecant and cot. So cot means if it is cosecant, you have to use the cot. If it is cot, cosecant has to come. Like that, you just remember. So just do remember, if the trigonometric ratio starts with the letter C, it's like an easy way to remembering. Okay, let us start. If it letter, I mean trigonometric ratio, if it start with the letter C, then minus sign. And for cosecant and cot, you can remember. So when to use the cosecant x? For what is the formula for the cosecant? Uh, just see the starting letter, ending letter, both are C. No, then cosecant x into cot x. So two functions together you have to write. That way you can remember. Now constant is for just a numerical value you have. So any numerical value, if you do the differentiation, by default 0. Okay, so as of now, these any formulas you can remember. Now some of the algebraic properties in the differentiation I'm going to explain, where u and v are two different functions. Okay, two different functions means, like suppose I can take x square and sin x, both are two different functions. Okay, now differentiation of this particular together we have to find out. So each term individually you can differentiate. X square differentiation using that formula, first formula, x square differentiation is what power, you have to bring it as a coefficient, then reduce 1 to the power, then 2x. And standard result sin x differentiation is what, cos x. That's all. So when two different functions, if it is in a product form, so basically if you have it as a terms, so each term individually you have to do the differentiation. So that's what the first one says, where u and v are some functions. If it is in terms of, I mean if it is in terms, so differentiate it individually. Then in case if it is in product, no, when two different functions, if it is in product, first do the differentiation of any one function at the time, then keep the other function as it is, then plus, then do the differentiation of the second function, keep the first function as it is. Okay, so doing the differentiation of both the functions together, it's wrong. So whenever two functions, if it is in product form, at a time, what you have to do, one function you differentiate, keep the other function as it is, then plus, then second function do the differentiation, keep the first function as it is. Okay, now u by v, so this one we call it as a product rule, and this one is a quotient rule. U by v, in case if two different functions, if it is in a product form, do the differentiation of the numerator function first, then into denominator function, then minus, now differentiation of the denominator function into numerator function, then whole divided by v square. Okay, so all this when to use, if two different functions, if it is in addition form, subtraction form, multiplication form and division form, we need to apply this as well. Okay, and thank you for watching. Now related to the exercise 5.2 sums, no, in next video I will continue. Thank you.